Hello, I'm Dr. Lawrence W. Moore, and welcome to Exploring Multimedia Art with L2Ork. This is Series 2, Episode 1. Welcome back to anybody who's been watching my first series on this subject, and welcome to anybody who's new, just checking this video out. If you are interested in this topic, I would highly recommend that you see Series 1. In Series 1, I use L2Ork right from the beginning, and it'll be easier for people who haven't had a background with Pure Data or L2Ork before. That being said, I should say a little bit about L2Ork. L2Ork is based upon Pure Data. In fact, Pure Data is at the core of it, but it comes with some extra features that are very useful for multimedia art. In Series 1, we went over some of these features, like its unique approach to data structures, which is for 2D visualizations and animations that basically you can use in an audio-reactive way or a MIDI-reactive way. It's a pretty open-ended programming environment. So basically you get a lot of interaction with your visuals from your music and audio, as well as MIDI. So it's great software. It's free. It's maintained by Ivica Eko-Bukvik at Virginia Tech, and I'll be showing you how you can get it in a moment. And for those of you who already have it, I'll give you the heads up that a little over a week ago, a new release came out, and you should probably check it out. So, that being said, what are we going to do today? Well, we're going to continue where we left off. The first half of the last series was on the L2Ork data structures. I'll probably return to them again in the future because there's so much you can do with them. But the second half was focused on GEM, which is the graphical environment for multimedia. That can also be installed as an external for PD Vanilla, and it can be used in other flavors of PD. But I like the fact that in L2Ork, whether you're using Mac, Windows, or Linux, you download L2Ork. It comes with GEM. You don't have to do anything, and it's a comparatively pretty stable version of GEM. GEM is something that over the years was not maintained for almost like 10 years. It's now being maintained again, and it's coming back, but over the years that it wasn't maintained, a lot of things just didn't quite work anymore as video cards advanced, and as new codecs came out and things. But there's a lot to it that is working and is very powerful, and I'm continuing along this line right now because I am very interested in making some audio-reactive visualizations for my music, and I know there's plenty of other people out there that would like to be able to do that, especially with free open source software. So okay, I believe that's enough of an intro, so let's get on to the episode. But more specifically, I should say what we're doing in this episode is working with particles. Particle systems is a powerful function within GEM, and it's great for making visualizations that react to audio as well as MIDI. So here we go. Here we are. This is where you can get L2Ork and its new version. If you're familiar with puredata.info, the Pure Data community website, you can also find it there. But I will also leave a link to this page in the description. This is where you can find the downloads, as well as below there are links to the source code if you would like to build it from source yourself. But we have the downloads here for like Ubuntu 22.04 and Ubuntu 20.04. Basically, those are Linux distributions. It is also available as a flat pack for you Linux users. That was just recently, like a little over a week ago. I saw it appear on FlatHub for the first time. So you can get it that way. Although if you use a distribution that's based on Ubuntu or is Ubuntu, I recommend the Ubuntu packages. It worked better for me that way. I'm using Linux Mint 21.2 Victoria, which is based on 22.04 Jammy Jellyfish of Ubuntu. Yep, 22.04. I didn't know if the 0 was there or not. But for Mac and Windows users, you can also download it from here. So yeah, this is the spot to get it. I will include it in the description. If you already have it, you may want to move on to the new version. I noticed, at least for me, there were some bug fixes, and yeah, I think it's probably a good idea to do that. A heads up for anybody that's new, if you go to Series 1, Episode 1B, I have some advice there for people that have trouble installing it, especially Mac users. You need to get around the fact that it's not on the list of, I guess, official Mac software, because, it's open source software, it's free, no one's really making money from this, so they don't pay to be on the, secure list of Mac software, so you have to basically be able to get around the security settings to install it. I had a class full of students. Many of them were Mac users. A couple had trouble, some didn't, but those that did were able to work it out. So that's fine and dandy. So anyway, that's where you get it. Whoosh. So here we are. This is a patch I just started. For those of you that were watching Series 1, I'm zooming in now. I now do zooms that you can see. Just to point out, you will see an extra mouse cursor appear. The big one is me, like pointing to the toggle here. The big mouse cursor is what I'm pointing. The other one is just an effect of the magnifier. I, at times, do need to zoom in on the screen, and I think this will also be helpful for some viewers that are like watching on cell phone or something. And then we'll work on the computer later or whatever. So in any case, this is setting up for Gem. Basically, the Gem Win object is necessary to open up the Gem window and have Gem run. Gem is going to run off of your video card, your GPU. So it is a little different as an external to PD in that regard. It's not running off of the CPU, but rather the GPU. And these messages are things that I like to use for opening and closing it. The first message begins with a reset, comma, space. You got to have the comma and spaces between these statements here in the message. Reset basically resets the window, so any previous resolutions or things that were fed to it are cleared out. And then I set the dimensions basically to make it 1280 by 720, which is HD proportions, a smaller HD that will fit on the screen here, but still be big enough to also be visually pleasing. But you can do full screen and other resolutions and so forth if you so desire, but I like for folks to be able to see both things on the same screen, this patch window as well as the Gem window. And create actually opens up the window, and 1 is a signal to start running. 0, destroy is whenever I want to close it. It turns it off with the 0, and destroy closes the window. I have a toggle here so that anytime I want to kind of like turn Gem on or off, I can. So I could turn it off without closing the window if I want to do some patching changes. A lot of times you could do some patching changes without actually turning it off, but I just have it there just in case. So that's what I've got. And if you were following in Series 1, some of you, now I don't know what everybody has or if things have changed in the new version, but I know that some of my Mac users in the when I was doing Series 1, the gem library wasn't loaded on startup and they were having trouble dealing with that. So you might need to do this. Like if you make a GemWin object and it's got the red outline saying it's not created, you may need to put in this statement, an object box, Control-1 or Command-1 in Mac, declare. I typed that wrong. Declare -lib gem, capital G, lowercase em. And that will basically make sure the gem library is loaded if it wasn't loaded on startup. And then you could probably make this object again and it will take form. Okay, I don't need that, so I'm going to just delete that, but that is something that's good to be aware of. So now I'm going to go into run mode, Control-E there, Command-E in Mac, just hit the message, and there's our gem window. So now let's get on to particle systems. Everything in gem that you make needs to start with a gem head. So make an object, gem head. You can put a priority number afterwards. Default is 51, but we're only going to be working with one gem list here, so I don't need to make a priority number. So yeah, this basically feeds the objects that we put in below it to run the system. And all the objects below are called a gem list. Now, since we're working with particles, there is also a particle head. Part_head. And that's just like the gem head for particles. And I'm actually going to move it down a little bit with the arrow keys. You can select objects and move them around with arrow keys. Helps you get them right where you want them. I'm leaving some space here because I'm going to be putting some things in after this. There's nothing to see over here yet. We haven't really put enough in to make something happen. So I will zoom out so we can see what happens once I get this process going. The next thing I'm going to make is Control-1. We're going to make a part source. Part_source. And I'm going to put an initial argument here, simply the number 1. We will expand on this afterwards to see more of what you can do with part source. I missed. I got the wrong inlet there. But for now, I'm just going to put 1. Now, the part source object basically gives you a source for your particle system. You may not know what particle systems are yet, but you will see it as we make it. But basically, it's an emitter, a particle emitter, where basically from the source, particles are created and they fly out in ways that you can shape and define, and that's what we'll be doing. So this is the source and kind of defines where they come from. The number 1 we're using for now is to say that we're going to create, or part source is going to create 1 particle per frames. And frames is like frame rate in video, or render frames, basically. We can change the frame rate, and we probably will later, just to see. But by default, without telling GemWin what the frame rate is, Gem operates at 20 frames per second. So this will be creating 1 particle 20 times per second. All right. and we'll be able to visualize that shortly. And then next we need part underscore kill old. Now, this isn't technically required, but it's a good idea. And to keep things simple to see how the whole thing works, I'm going to put in the number 1 for now. But basically what this does is as particles are created and sent out, this is how soon our particle is going to be destroyed and flicker out of existence, basically. And if you don't have this, what I've found is it'll generate particles and they'll go on forever, expand out of view. You don't see them anymore, but they're still technically there. And then for some reason, it stops making particles after a while. So you kind of need to end them in order to get more particles, at least from my experience, because I've played around with it. And then at the end, we need part draw. This actually draws them, and you can add different messages to this to shape that drawing and control it a bit. I'm once again going to leave space here because we're eventually going to put some things in between. Okay, so now that I've done that, let me just kind of turn this on, off, on again, make sure things are on. At this point, I am not seeing anything, so there's something else that I do need to do. Okay, I have done that something else, and it's not something that you would normally really need to do, but the way I set things up, I wanted to set things up to simplify things and to kind of make a point to understand about the source, the frames, and the killing off of the particles and all that stuff. Basically, it did work, but they just weren't quite visible. Let me show you these 2 messages I created. These are messages that can be sent into part draw. One is called draw line, which basically draws the particles that are coming out as line segments. Now, when I hit that, you see it's gone blank over here. And when I hit draw point, we can actually see these little points here. It's hard to see, but there they are. Now, part of the reason here is because the resolution that I'm using is a little bit higher. Things are going to look a little smaller. And I'm generating 1 part per frame, 1 particle per frame. And then at the same time, I'm killing them off after 1. So 1, I believe, in this case means frames. Let's try making that 10. Now you see this little cloud of particles has gotten a bit bigger. Okay, now they are really emanating from the source and kind of moving outwards from that source. We haven't really defined the source fully. There's more that we can say to it, to say about the source of the particle system. And we're going to do that in a moment. But now that we changed this to a higher value, because this is time, this is not number of particles. This means kill old after like 10 frames. You can hit draw line now, and I can I don't see anything right now, once again. So it looks like draw line is the default. Draw point, we actually see something. Now, trust me, it gets better. We have other things that we can do in addition to source, but let's play with the source a little bit here. part source, we're only creating 1 per frame. Let's try creating 10. Now we see much more of a thing going on here. Let's see if we can still see them if we go to line. No. This is the first time I've had this, and the main thing that's different is the resolution. I've been able to put it on draw line before and see them quite clearly. So let's work with this a little bit more. See, our source is right here in the center, and that tends to be a default. But in source, and you can right click on it and go to help to see some of the things that you can tell it. Other than the leftmost inlet, which is part of the part list and gem list, you have one inlet where you can put in the number of particles being generated per frame, and then the domain. This has to do with like a shape of where it's coming from. And then you have information that helps define that domain. For example, if I'm going to make a domain, and that help file tells you the different domains, but it's kind of sparse. It doesn't give you all the arguments that you should put for each type of domain. But a common domain to use is sphere. Now these could be fed in through those inlets, but I'm just typing them in as creation arguments, which will give us a good starting point. We want to get this to like a nice stable visualization, and then we could feed it other things through its inlets later. Now, if we're going to say that its domain is a sphere, we got to then give coordinates of where that sphere is. X, Y, and Z. I'm going to put 0 for all that, which basically is center. X is horizontal axis, Y is vertical, and Z is depth. And then you need to put in a radius. I'm going to put in a radius of 2. And that is basically kind of giving a domain of a sphere origin for the particles. Now, I thought 2 would give me a bigger source here. I think what we really need to do to enlarge this is to deal with its destination in a way, which is something called part velocity. So I'm going to select all this stuff and move it down. Now, it's called part velocity, but as I see it, it seems to be more of a defining of the area in which these particles flying out, arrive to, in a way. Part velocity. Now, this one, you do want to, at the beginning, give it more information. Unlike source, you don't put in the number of particles. You go immediately to the domain, sphere. And I'm going to give it the same center point as the source, but I am going to make this one also 2, but this time I think we're going to see the particles spread out further, because now it's their destination as opposed to their source. There we go. There, now we're seeing stars. We're flying through stars. And now let's see if we can draw a line. Yep, there we go. Basically, with part source, you're kind of like giving it a source, but you're not going to see much of moving particles until you give it a destination. So let me just experiment here a bit. I'm going to change the part velocity's radius, the radius of its sphere, from 2 to something like 0.5. Now, I saw a slight change there. The particles are kind of like disappearing a little bit earlier, but what would really kind of affect that is our kill old. Let's lower it to 5. There we go. Now they're dying off sooner, so they can't get as far away. So that part velocity is kind of like the speed of them getting out to somewhere, but you give them a bit of a perspective to get to. We can give their destination through part velocity some coordinate changes to move them somewhere. Like, let's have them go a little more to the left. So that would be the x coordinate here. And we're going to just say 1. Well, to the right. Yeah, -1 would have been to the left. So it's coming from 0, going out to -1 on the x-axis. So anyway, that's pretty cool. Yeah, now let me show you a few other things here. Because we have the lines, we have the points, and then there's another thing we can do with part draw. You can also type a draw message, put in a $1, which means a variable, and that $1 is something that we're going to basically define with a number box. So I'm putting a number box right above it, Control 3. Now, this number box, I'm going to go into run mode and type into it, as opposed to scrolling on it, because the numbers get a little too high too quick. I'm going to put in 1. We don't see any difference there. That seems to be kind of default. This seems to be oriented with how the lines are formed. If I put in 2, look at that. It looks like the lines are given more of a 2-dimensionality to them. Now I'm going to put 3 to it. A little different, maybe a more 3-dimensionality to the line segments. Now I'm going to put 4. And look at that, they get thick. And then I'm going to put 5. They get even thicker. Now when I go to 6, yeah, it looks like it's even still thicker. Let me go 7. Now that seemed to get thinner again. 8, oh, well, that got thicker. 9. Yeah, I think, oh, there at 10, we seem to reset back to something closer to 2. It's kind of interesting, this. Let's try 11. 12. Yeah, it looks like your range is really going to be 1 through 10. Let's try 0. Yeah, that didn't help. We got points again. Yeah, let's leave it at... I don't see a big difference between 2 and 3. Maybe we'll leave it at 4. All right. So anyway, there you go. That's another thing you could do with draw. Now we will, and it'll probably be in the next episode, we could use an object called render to make these particles into other things. And that really increases the cool factor. But I want to show you more of the basics here. Now, kill old is set at 5. If we set it at 1, it'll make this whole formation much shorter. Yeah, you see that? Yeah. But the kill old object can receive values in through its rightmost inlet. And so you can have those change. Let's say, for example, we'll put a number box for now. And then I'm going to scroll through this. Now, when you go into run mode and click and scroll, it scrolls through integers. So you get a big change in values. And the numbers like 1, 2, 3, 4, that is kind of like spatial orientation in GEM. And remember, if you've seen series 1, they tend to be, they're like regions size as opposed to pixels. So it's kind of harder to work with in that way, but it is something where the values like 1 to 2 to 3 can be big jumps, in other words. So what I'm going to do here is put in a multiplier times 0.1. So that way, when I scroll over this number box, now it'll increase and decrease with each scroll or each scroll unit by 0.1. Whoa. I'm sorry. I didn't mean to do that, folks. Okay. So now let's go into run mode. Let's zoom out so we can see what happens as I scroll on this. See, I get a more resolution or more control over this. I could probably even put it at 0.01 here. Yeah. Gives me a little bit more control over it. Yeah. There we go. So let's say we like that. What are some other things that can be done? Well, I'm going to zoom in over here so you can see what I'm doing. We have our velocity here, but as you see, there are inlets for this where you can say domain and then the coordinates for the domain. The thing is, the coordinates need to make sense with what the domain is. So if we, and remember, part velocity deals with kind of like the destination. If you put in sphere, you're not really going to necessarily see a sphere shape, depending on where it's positioned. Those emissions are going out to a spherical area, but it's kind of hard to, since they are particles, it's kind of hard to see it form a sphere, so you don't really see that. You can do like a line segment, in which case you need to put 2 sets of coordinates. The origin, 0, 0, 0, and destination. How about we're going to do it to the right one, and then we're going to put it down 1 on the vertical axis. Oh, actually, that actually goes up. So it's going to be to the right and up, and we'll leave z at 0. Down. Sorry. Yeah, -1 is down in y coordinates. So there we go. But as you see, it's narrowed because its destination is kind of like a point here. It's a line from here to here. Of course, source has an effect on it. I mean, some of the stuff can be a little bit, what am I making here? But it's fun. Let's go back to sphere. There's sphere and triangle. Triangle, of course, would need to be given information afterwards that's relevant to a triangle, and then there's cylinder. I think sphere is the easiest to use. So I'm going to make it go just outwards in all directions by making it zeros, and then give it a radius of, how about 1? So there we are. We're going out all directions because it's almost like going out to a sphere around the source. That center is 0, 0, 0, and its radius out to its outer circumference, or in the case of a sphere, it would be, yeah, something like that, 3-dimensional circumference. It's kind of radiating out to that. So anyway, that looks pretty cool. Now, some other things you can control. I'm not going to do much with source, although you can use a number box to change like the number of particles being created. Although with that thickness, they're not really looking like particles right now. So we could put a number box here, and it would be this inlet. These inlets, remember, receive domain and then the information for the domain. So if you send it like sphere in here, you got to send it like 4 numbers that are relevant to defining the sphere. So when you're sending messages like that, you got to be kind of careful that you're sending information that would work. So let's zoom out here, and I'm going to scroll through this number box to see what we got. A lot more being created per frame. Now, speaking of frame rate, let's experiment with changing the frame rate. I'm going to destroy the gem window. And I'm going to put in here in this message, just before it creates the window, let's define the frame rate. That is frames. And let's make it 1. And then we're going to make our particle creation just 1. All right. And we'll leave everything else the same as its defaults. When we create this again, the number boxes won't have effect. It'll be the numbers that are creation arguments. So we're getting a frame rate of 1. So it should be 1 particle per second, but seems to be more than that. Maybe 2 or 3. Well, if it's per second, it would really be like, yeah, maybe close to 10. Maybe it's still retaining some information from before. Let me just type into here 1. Well, there is another thing that could be a factor in this. There is a thing called speed that you can send to part head. Speed, I'll put $1 so we can use a number box to define that speed. Although I'll be typing numbers in, because when I was playing with this before, I noticed that sometimes it was cool to use floating point numbers. All right, so now I'm going to put in 1. I think that may be the default. Now this should be the speed of generation of the particles. I don't know how that fits in with the frame rate. And in fact, maybe putting frames 1 in was something that Gem didn't accept. Maybe the minimum frame rate is something like 5 frames per second or something like that. But let's try a speed of 5 now. Whoa. That was a big difference. Now, the thing is, it looks bigger because if you think about it, particles flying out, if they're going out faster, they're going to make a longer path. And so you kind of need to use your imagination in thinking about this and how things are going to end up looking. I'm going to put in here 0.1. Oh, yeah. That would be cool beans there. Let's make our source 10 here, so we're getting more generated. And if we want them to not disappear as soon, remember our kill number would need to be higher. Let's try 20. Oh. Oh, that's right. I'm multiplying by 0.01. So, yeah, that would have something to do with it. 200. Or shall we say 2,000? There we go. Let me take a screenshot of this for the episode. Yep, I'm going to save that. Oh, you just getting this window? Well, I'll take that picture and then include it with this. Let me click on. I thought it was taking the whole screen. But it's doing windows. There we go. So I got pictures of them separately. That's good. So now we can colorize these. And the order, I think, I've seen varying orders, sometimes where source was below velocity even. Although for me, I prefer to have source above velocity. But let me put this down here. The object is part color. Now they're going to disappear here when I delete this. Cut the cord. There we go. Part color. And you can put in a creation argument. And it would be 2 sets of color information. They're RGB channels, red, green, blue. And Jim handles those value ranges as 0 to 1, not like 0 to 255 as is customary. So let's say we want varying shades of green and blue, my favorite colors. So 0 for red. You have a first set that is going to be like the bottom of the range, and the next one the top of the range. So we're going to say we can be at 0.1 in the green and blue channels. Then put another space, and then another set of RGB numbers, 0, 1, 1, like the full power to the color channels, green and blue, basically. Brightness is how it would appear. And we didn't get anything. Maybe it doesn't have creation arguments. Maybe you have to just pop it in through messages. Yeah, it looks like they're just popping it in through messages. Perhaps it doesn't do creation arguments. Yeah, this is the first time I tried just putting in the creation argument. So part color. And then we're going to make a message box for beginning of our range, just like I did before. And then 0, 1, 1. So it assigns a color within this range to each particle as it's generated. So I'm going to now tap these messages in. And it doesn't take effect until both get tapped in. So you'd probably want to make a bang that hits both message boxes at the same time. How about I take another picture? That looks more interesting. There we go. Yeah. Gotta do the stuff that I need to do to make the series reach more people. And by the way, if you've been enjoying this content or found it useful in any way, please hit the like button. It really helps the channel out. Please subscribe if you haven't already. And share on social media, Leave a comment. All those types of interactions help. Okay. Now, if we go back to points, oh no, we lost all that beauty. So let's go back here to like 4. There we are. So anyway, we can speed this up though. Now, if I scroll on this, the values will change pretty suddenly. So once again, the speed, I scrolled in wrong for my magnification. I hit the wrong button, and it did scroll, but in a different way than I wanted to. Okay, so let's edit, and let's put a multiplier in 0.1 or 0.01 in between the number box and the message. There we go. Times 0.01. Now what I want to do is make eventually like some sub patches that are modular for generating particles and shapes and things, and using them in various, so I don't have to make trees like this again, and basically having number boxes on like a nice little rectangular modular box where I could type in information and have inlets on it so I could feed it information and change all these values in a nicer way. Look at this. There we go. We get more resolution on the speed of change. Slow down. Oh, we're at a standstill now. Look at that. All right, some cool stuff there. Let's see how it looks as just the regular lines. Draw a line. Now, these different things that I'm interacting with here can be fed values based on audio data coming in, and that's eventually what I really want to do. But one thing, hey, let me see here. Can I type in 2.5? No, I think this command only accepts integers. Yeah, and there's a big difference between 3 and 4. I don't think there's any middle ground like 3.5. Yeah, no, it's either below 4. Yeah, I think it just accepts integers, and they have a certain meaning as far as what these lines are going to be like. All right, so let's try something else here. I'm going to add one more thing in this episode. We're going to go on with particles in the next episode and do more things, especially when you see render. You're going to be like, oh, that's cool. But we're going to include a little bit of something that we've done in Series 1 using a rather commonly used gem transform in a way, the rotate XYZ object. So I'm going to put this down and put rotate XYZ here. I don't know how critical is its location in the list, but I think just before draw is a good place. So rotate XYZ, and it's important to capitalize the XYZ there. We don't want to rotate on the x-axis, or at least I'm not planning to, so I'm going to put a 0 there, nor on the y-axis, but I will rotate on the z-axis and put a $1 there. Now, rotate XYZ, you can basically choose one of the 3 axes to have rotation on. And rotation is expressed in degrees, 360 meaning we've gone full circle, so to speak. The x-axis would be, it would rotate on a horizontal axis going across the screen left to right. The y-axis would mean it would rotate on a vertical axis going from top to bottom. I think that big change there was because I had cut the cable and then reinitiated it, so a lot of the particles hadn't died off yet, and now they did, so now it's more like it was. It wasn't anything I did there. So anyway, yeah, and then the Z would be like, if you could imagine an axis that's coming from back into the screen, coming forward towards you, and that's what I want to rotate on, so it'll kind of rotate in a circle like this. And what I'm going to do is use the Metro object to do it. Our good old friend Metro, which will send out a bang every however many milliseconds I say. Maybe 10 times per second. How about every 100 milliseconds? And then I'm going to put in here a float box where the number goes, where a number gets stored. And then we're going to add to it 10 times per second. We're going to add 10 degrees. Okay, so this will go out of here into here. Missed. And then this goes back into here where it waits to get banged again to be added to again. Okay, now let me move this down here. So it's going to be counting up by 10 degrees, 10 times per second. That means in 1 second it'll be like 100 degrees. Let's put it at 5. That might be a little fast. All right, and then it'll definitely start at 0 since it's not being fed a number to begin with. And then it won't straighten up. Hey, I don't need to worry about that. And then to make sure it keeps going in the range of 0 to 360, I'm going to put mod 360. And then let's get a number box here so we can actually see what we're feeding into rotate X, Y, Z. You give this a little more space. And feed this into the ZX, the Z coordinate. All right. Then we just need to start Metro with a bang. Can either make a bang or send it a message that says bang. Either way will do. And then to stop it, let's put a stop message there too. Okay. I didn't mean to do that. All right, so we're going to zoom out. Now let's hit bang and see what happens. Oh yeah. We've got ourselves some rotating particles. And we have here the color range. You could put $1 variables into these and send in changing numbers. You have to send them to both. You have to send different numbers to both. So there is a range, and they kind of need to arrive to both. I guess you could do one, and one would serve as the minimum and the other as the maximum. But, you know, there's all sorts of things you can send values here to get stuff. Let me see here. I'm thinking of, let's see, 20. This is going into source, right? Yeah, it is. 30. Yeah, it should be getting thicker because more particles are being generated per second or per frame. Look at that. That's beautiful stuff. So anyway, you can see where this is going, and there's plenty more to do. Now, you could always make multiple particle systems and have them interact. There is priority, once again, and that you can use to say which one's on top. Look at that. Beautiful stuff. And yeah, and the way you do that is in gemhead, put a creation argument, or you could send it a number through the number box. Without any creation argument, the default is 51. And so I believe it's the higher numbers to get more priority. So 52 would be on top of this, and you would see 51 below this. Yeah, so you could basically overlap them. You know what? Should I try that? Okay, I think I selected the whole thing. Select it, and I'm hitting Control D to duplicate. There we go. Drag it over here. Now, you see that? The new one is the white because it wasn't sent the color messages that the other one was. Since they didn't arrive yet, it's the white. Now, what I could do is put this gem head, give it a number 50. And I believe 51 is the default. But I'll put 51 over here just to make sure. Maybe it's the lower numbers that are on top. $49. I'm not crazy here. Well, let's destroy it and create it again. And let's send this one its colors. Let's thin this one out. Yeah, it looks like I'm not getting the priority that I thought I would. Let me set this at a priority of 1. How about that? Let's differentiate these. I sent the color changes, but I'm seeing no green and blue. Here, let's scroll over here. I probably shouldn't have done this. I should have quit while I was ahead. I can't. I don't have a scroll bar. Yeah, I do. Okay. Let's give this one some differentiation. Let's thin it out. Let's give this one a 0.1 speed. Slow it down. Let us give it. We're still creating one source at a time. Make sure it's at 1. And how about we give this one. Yeah, let's change these. How about this one be the green, and then this one be the blue? Or no, keep it the way. Yeah, let's do that. 0. This will be green. Ranges. Come on. And this one will be, and the other one will be blue ranges. So let's pump these in, see if we get color changes. Now we're starting to get them as they're emitted. Okay. And then this one is going to be blue here. Now, I didn't get the priority that I wanted there. I'm going to go back and take a look at that. Come on, will you? There we go. 1. Okay. Let's see if any blues come into this. And let's differentiate them a little bit more. Yeah, we're getting a hell of a lot of green. That seems to be on top. I'm going to see here. Part head. Is there priorities in it? No, just speed. I would have to read those things just to see more. But gem head. You see, here it is. Here's the priorities. 50 and 105. Well, let's try further apart numbers like that and see what we get. 50 and 105. Oh, we're starting to see, I saw a little blue there. Yeah, we're still getting a hell of a lot of green. Well, it is the 105. Let's change this. Make you 105. And you 50. Now, I wonder if I need to turn them off and back on again. Now that they have new priority numbers. Let's make a toggle for both. Turn them on and off. Come on. No. Give me the cable. Will you please? There we go. There, they're off, back on. No, it's putting green on top no matter what. Yeah, I'm going to have to check that out. But there is probably a better way of doing this sort of thing, interlacing these different particles. And I'm going to be looking into that before next time for sure. Let's get rid of those. Now the blue will be taking over. But I'm going to put this range back to the way it was. So that blue and green are mixed together. But you can have multiple particle systems. Perhaps the way to do it best is to use a separator. There is a separator object in GEM. And perhaps thin these out a bit if we had multiple ones, if the things weren't so thick. What are these number boxes doing there? Oh, one of them was the one I was using. Yeah. Yep. And that's what I was going to do right now. And I just made another one. All right, so let's do 2. Thin these lines out. Yeah, that's looking pretty cool. So we do this and this. Yeah, so anyway, hopefully you've gotten some pleasure out of this or some information out of this. I'll be exploring this further. This will be multi-part on particle systems. There's definitely more to explore here, but as you see, it has a lot of potential. Definitely with more practice in setting like good kill old times and so forth, you could basically have like different layers that don't step on each other or cover each other up too much, but rather interlace. And that's something I'd like to work towards, just to have a more dynamic system going on. So anyway, next time we'll be looking into that, and well, I'll look into it in the meantime. And then we'll also be looking at render and some other things that we can use to kind of like make these particles more interesting and more dynamic and change. All right, folks, thank you for joining me. I hope you had a good time. Please like, share, subscribe, help the channel out a little bit. Leave a comment. Tell me how you feel. Or if you have questions, let me know, and I'll endeavor to answer them. Until next time, take care and stay free.